Hello, this is Ms. Pettigrew, and today we're going to start Unit 5. We're going to take a look at Lesson 1, which is solving systems of equations by graphing. What is a system of equations? All of this needs to be in your notes. A system of equations is when you have two or more equations using the same variables. And then the solution to the system is the point that satisfies all of the equations. This point will be an ordered pair. So your solution or your answer is going to be an ordered pair. It's going to make both equations true, or all equations true. Alright, so make sure that's in your notes, and then let's get started. Let's start by looking at example number 1. You have two linear equations here. Y is equal to x minus 5, and y is equal to negative 2x plus 4. We're going to graph both of these and get our solution. So let's start by graphing y is equal to x minus 5. So start at negative 5, and then rise 1 and run 1 to continue that line. Let's go ahead and make that line a little bit straighter. Alright, so there's your line y is equal to x minus 5. And then you have the equation y is equal to negative 2x plus 4. So you want to start at 4 on the y-axis. And then use your slope of negative 2 to continue the line. And you should already see where they're crossing over each other. Let's go ahead and draw the line. Alright, so we're going to zone in on that red dot right here where they intersect. And where they intersect is going to be positive 3, negative 2. Positive 3, negative 2. Now we want to make sure that we did this correctly, so we're going to put this point into both equations to check. Remember that the ordered pair is in the form of x comma y, so we can replace those variables in the original equation. So y is negative 2 is equal to 3 minus 5. Negative 2 does equal negative 2, so that one checks. And then we'll do it for the second equation. Put in negative 2 is equal to negative 2 times the x value, which is 3, plus 4. So negative 2 equals negative 6 plus 4. And negative 6 plus 4 is negative 2, so it checks as well. So we know that we have a solution that is correct. So the solution to this equation would be, or to this system would be negative, or positive 3, negative 2. Alright, for number 2, we have two equations again. The first one is not in slope-intercept form, so we need to isolate y first. So let's go ahead and do that. We're going to add 5 to both sides. So now y equals x plus 5. And in your second equation, it's already isolated. Y is by itself. So y is equal to negative 1/3 x plus 1. Alright, let's go ahead and graph each line. The first line is going to start at positive 5 for the y-intercept, and it's going to have a slope of positive 1. So use that to extend your line. Okay. Then we're going to go ahead and graph the second line. It's going to start at positive 1 on the y-axis, and we're going to use a slope of negative 1/3. So we're going to go up and to the left 3 so that we hit that line. Okay, and you see right there where we've made the red dot that we have our intersection point, which is going to be negative 3, positive 2. And so we want to make sure that we solve this correctly. So we're going to go back to the original equations and plug in to the variables. So x is negative 3 equals 2 minus 5, and 2 minus 5 does equal negative 3, so that one checks. And we'll do the same thing for the second equation. So that's negative 1/3 times 3, times negative 3, excuse me. Then we're going to add 1, and that should equal 2. So negative 1/3 times negative 3 is positive 1. Add 1 to that, and you do get 2. So again, we have a true statement. So the ordered pair negative 3, positive 2 is our solution to this equation. All right, let's go ahead and have you do these two, number 3 and number 4, in your notes for homework this evening, and we will pick up with this in class tomorrow. Remember to isolate for y for any of the equations that are not currently isolated for y. Have a great evening.